The Doppler principle is used to establish the relative speed of a moving object by measurement of a radio frequency and the determination of the difference between the transmitted and the received frequencies. The Doppler effect is based upon the principle that a received frequency will only be the same as the transmitted frequency, provided there is no relative movement between the receiver and the transmitter. When there is relative movement, such as when a police car approaches a person, the pitch of the car's siren gets higher as it approaches because the intervals between the arriving wavefronts are shortened. After the car goes past the individual, the car's siren gets lower in pitch because the wavefronts reach the individual in longer intervals. The frequency therefore changes when there is relative movement between a transmitter and a receiver. Suppose you are at a sushi bar watching the dishes go by. As long as you stay still, the dishes will go by at a constant speed. If the dishes, which represent radio waves, travel at 100 meters a minute, and they are spaced 10 meters apart, then 10 dishes will go past in a minute, one every 6 seconds. In terms of radio waves, if the transmitter and receiver do not change velocity, the wave frequency will be the same. If you now walk at 20 meters a minute towards the direction of the oncoming dishes, then your joint speed will be 100 plus 20 meters a minute. This means that 12 dishes will now pass you in 1 minute, one every 5 seconds. If there is a convergence, the frequency increases. If you now walk at 20 meters a minute in the same direction as the dishes, then your joint speed is 100 minus 20 meters a second. This means that only 8 dishes will pass you in a minute, one every 7.5 seconds. If there is a divergence, the frequency decreases. Thus, it can be seen that the difference between transmitted and received frequencies is directly proportional to the relative velocity between the receiver and the transmitter. The faster the speed, as objects converge, the higher the frequency, or pitch in the case of sound waves. Similarly, the faster the speed, as objects diverge, the lower the frequency or pitch. The difference between the received frequency and the transmitted frequency is known as Doppler shift, or beat frequency. Let us now put some numbers to this Doppler shift principle. Remember that all calculations have to be on the basis of meters per second, because frequency and speed of light are described in units per second. The formula for calculating Doppler shift, sometimes called Doppler frequency, FD, is transmitter frequency in meters per second, F, times receiver speed in meters per second, V, divided by the speed of light in meters per second, C. For example, if an aircraft is flying at a speed of 486 knots directly towards a beacon transmitting on a frequency of 15 GHz, what will be the change in frequency? The Doppler shift. Convert everything into units per second. There are 1,850 meters in a nautical mile. So in 486 nautical miles, there are 899,100 meters. This is a figure for 1 hour, so in 1 second, divide by 3,600, which gives us 250 meters per second. The frequency of the transmitter, F, is given as 15 GHz, written as 15 times 10 to the power of 9. The speed of light, c, is written as 3 times 10 to the 8th. If we put this all together, there is a Doppler shift of 12.5 kHz. Let's use the same formula to find the speed at which an object is moving. Here's the question. The frequency shift observed at a stationary receiver from an object transmitting at a frequency of 18 GHz is 2.7 kHz. What is the speed of the object in miles per hour? So, as we are looking for v, the formula is transposed to read v equals fd times c over f. We are given fd as 2.7 kHz, which is written as 2.7 times 10 cube meters per second. C is 3 times 10 to the 8th. The transmitter frequency is given as 18 GHz, written as 18 times 10 to the power of 9. Put this all together, and the answer is 45 meters per second. We need to state this as miles per hour. 45 times 3,600 gives us 162,000 meters per hour. There are 1,610 meters in a statute mile, so the speed in miles per hour is 162,000 divided by 1,610, which is close to 100 miles per hour. The Doppler principle is used in VHF direction finding, radar, and VOR equipment, all of which we will look at in their own lessons. An airborne Doppler navigation system uses this principle to measure aircraft ground speed and drift. However, this is old-fashioned technology now, and airborne Doppler has been superseded by inertial-based systems for navigation. Doppler may still be found in helicopters, where it can be useful for auto-hover. Let's summarize this lesson. The Doppler principle is used to establish the relative speed of a moving object by measurement of a radio frequency and the determination of the difference between the transmitted and the received frequencies. We looked at the principle on which it operates. The faster the speed, as objects converge, the higher the frequency, or pitch in the case of sound waves. Similarly, the faster the speed, as objects diverge, the lower the frequency or pitch. This difference is known as Doppler shift. The Doppler principle is used in VHF direction finding, radar, and VOR equipment, all of which we will look at in their own lessons. In the air, it used to be a source of drift and ground speed, but is now only used in helicopters for auto-hover. This concludes the lesson on Doppler.